Run an AI agent as a standard app on your desktop, and it stops working the second your computer goes to sleep. Close the terminal, and your workflow shatters. But when you put that same agent on a dedicated server, it works for you 24/7. Your objective is to build a completely isolated, reboot-proof AI agent running locally on a Raspberry Pi. We are taking the OpenClaw platform and making it a secure, system-owned service. To accomplish this, you need three specific components: a Raspberry Pi 5, a 256GB micro SD card, and an Anthropic Claude API key. Running an AI on an open desktop shell leaves it exposed to random crashes and security flaws. By treating the agent as core infrastructure from day one, you lock down its permissions and ensure it recovers automatically from any failure. Step 1 is flashing the operating system. Open the Raspberry Pi imager on your main computer. Select the 64-bit Debian-based Raspberry Pi OS and target your SD card. Before writing the OS, go into the imager settings and explicitly disable password authentication. Passwords are a known vulnerability. Attackers run automated scripts to guess them thousands of times a minute. But an SSH key is a cryptographic pair of files. If an attacker lacks the exact matching private key, the server mathematically rejects the connection immediately. Generate an SSH key on your main computer using your terminal. Then copy the resulting public key file and paste that exact string of text into the Pi imager's public key field before hitting write. Once the Pi boots up and connects to your network, SSHN from your main computer. Your first task is installing Node.js, the runtime environment OpenClaw requires, globally on the system using a standard curl command. Warning tone: do not use local package managers like NVM. NVM stands for Node Version Manager, and it installs Node inside a specific user's folder. System daemons, which are background programs that run without human intervention, will fail to find those localized files. A secure, globally accessible runtime environment is required before any AI logic touches this hardware. Step 2 is isolation. We create a dedicated system user specifically for OpenClaw, applying flags to the account so it has zero interactive login capabilities. This system hierarchy separates the OpenClaw user from the root human user to build a containment zone. If a malicious prompt triggers a rogue command, it hits an absolute permission wall, unable to read outside files or open a shell. Now, download the OpenClaw installation script. Instead of running it immediately, save it into a neutral, temporary directory. Before executing that script, switch your terminal session into the restricted OpenClaw user context. This guarantees all resulting files are owned by the service, not by you. Run the installer. During the onboarding flow, paste your Anthropic API key and select your default model. Out of the box, OpenClaw can spawn multiple sub-agents simultaneously. If left unchecked during testing, a simple error can trigger a massive fan-out of parallel requests, burning through your API budget in minutes. Open the openclaw.json configuration file in a text editor and change the max concurrent value to 1. This sets a hard limit on how many processes the agent can run at once. Your agent is now installed, trapped inside a rigid permission structure and bound by strict financial limits. Step 3 is making the system permanent. Create a symlink, a shortcut file, for the OpenClaw binary in the /user/local/bin directory. This establishes a single source of truth for the system to execute. Next, we hand control over to systemd. Systemd is the core initialization system in Linux that manages background services. If the OpenClaw process crashes, systemd instantly restarts it, without you having to type a single command. Create a new .service file in the systemd directory. This file dictates exactly which user to run the agent as, where the binary is located, and what to do if a failure occurs. Run the commands to reload the systemd daemon so it registers your new file. Then enable the OpenClaw service so it boots automatically on startup and start it immediately. Check your work by typing systemctl status OpenClaw. You want to see a bright green active indicator in your terminal. Now for the real test. Type sudo reboot to kick yourself out of the shell entirely and force the Raspberry Pi to restart. The operating system is now the boss. Your laptop dying, closing your terminal session, or a sudden power outage will no longer permanently kill your AI agent. Once the Pi is back online, SSH into the machine again and run the status command. The service will already be active, confirming it survived the reboot completely on its own. You can jump right into interacting with it by launching the TUI, or Terminal User Interface, passing prompts directly to your local agent. Or use an SSH port forwarding command to securely route traffic to your main computer. This lets you open a desktop browser and manage your agent through the clean, visual web dashboard. You have successfully turned a fragile local script into bulletproof infrastructure. Your hardware is locked down, your API costs are capped, and your agent is ready to handle multimodal routing and automated daily workflows.